Clinical myotonia is a sustained muscle contraction after voluntary activity. A myotonic discharge correlates with this phenomenon. However, it can also be seen without clinical myotonia. Myotonic discharges are seen during assessment of insertional and spontaneous activity. They can also occur during voluntary contraction and interfere with the assessment of motor action potential waveforms. Tapping on the muscle can produce myotonic discharges on the EMG recordings. This is called percussion myotonia. A gain of 50 to 200 microvolts per division is quite adequate to see the discharge. The sweep speed is usually 10 milliseconds per division. The signals are displayed in a free-running EMG mode. Using a slow sweep, for example 50 or 100 milliseconds per division, can help better visualize the change in the signal during the discharge. A single muscle fiber produces a myotonic discharge. The shape, amplitude, and firing rate all can change during the discharge as seen in this recording. The change is gradual. As example, the firing rate will slowly increase and then gradually reduce and then increase again. This is called waxing and waning. The frequency varies from 20 to 80 Hz, but decreases as the discharge comes to a stop. Very low frequency myotonic discharges have also been reported. The signal amplitude is variable from 50 to 1000 microvolts. The single fiber potential in the myotonic discharge can be seen in any of its three configurations: fibrillation, positive shock wave, or the end plate spike. Due to the short duration of the single fiber action potential, the EMG has a high-pitch sound. With waxing and waning, the EMG has a characteristic sound described as dive bomber or revving a motorcycle. The EMG signal can contain many such discharges. Even in a complex signal such as this, one can easily hear distinct myotonic discharges. A myotonic discharge reflects unstable muscle fiber membrane, usually from reduced chloride conductance. During an action potential, the muscle fiber is depolarized by flow of sodium ions, and then it becomes hyperpolarized by flow of potassium ions. The return to resting state from hyperpolarization requires a slight depolarization. This process is aided by chloride ions. With reduced chloride conductance, the depolarization from the hyperpolarized state can start a new action potential, and the process will repeat, and thus the discharge. The change in amplitude, frequency, and shape probably reflects the gradual recovery of the fiber to its resting state during the discharge. Myotonic discharges are seen with clinical myotonia in diseases like myotonic dystrophy of type 1 and 2, myotonia congenita, etc. It is also seen in patients without clinical myotonia in conditions such as myositis and metabolic muscle diseases.